Welcome back everybody. In this video we'll be getting the dials to work on this salvage dash. So in the previous video we got this dash and we didn't know much about it, and we managed to figure out how to power it and get the data lines from it so we could at least receive data coming out of the unit. So now in today's video we're going to try and send data to the unit and try and control all these dials and lights and things and see how we get that up and running. So in this video we will be sending down CANBUS data to this device. Don't think, well, it's cool, I'll try and use it on my car, because you'll brick your car. So if you send any data randomly down to your car, a working car, you'll brick it. Just don't do it. So on this one we've got the device by itself, we've got no other parts. We're just basically sending messages to try and get it to do something, and we'll be spamming all these different addresses and you don't know what it's going to do in your car. So getting the crux of CANBUS, basically it's a network of all your devices and there's data being sent down to it, and at the beginning of each bit of the data we've got three parts to this message. We've got an ID which one of these devices is listening for, and we've got a byte which tells how long the message is, and then the payload or the message itself. So what's happening is these messages are scrolling through your car's network, and a message gets to this device, it sees it, doesn't know what it is, ignores it, sees the next one and says, oh yes, I know what to do with that one, and then performs the action within those bytes of payload. So in that message there's an address, and an address might control part of this device or whatever device it's sending to, or it might control the whole thing. For this particular dash, some of this one address controls, I think, the speedo and the rev counter. Another message controls the temperature and the lights, and there might be devices on here which don't work that way at all. So some of the lights on here for like the seatbelt and things like that are mechanical switches. They aren't controlled by CANBUS at all, and the fuel gauge I think as well is a variable resistor, so there's no way we can set that. So I've got a couple of questions to answer here. Do I need to send a certain sequence of messages for things to start working? If I send too many messages, does the unit turn off? What is the construction of the message? What do those bytes need to be sent down as? All those things we're going to cover today. So what we'll do is we'll set up on the bench and go through and do some testing. So we've got a test rig set up here, but somehow we're going to try and test all these IDs to see which one makes the dials and things move on the dash. And what we could do is we could get one of those IDs and with the 8 bits test every single bit in a different sequence to see if it makes anything change. But we couldn't really do that, because if you fix one CAN ID and only vary the 8 data bytes, it would take you 585,000 years to process every combination if you send it down at 1 microsecond per message. I've got a lot on, I don't have time to do that, so we need to just take a big foul swoop and do a whole bunch of them at the same value. So to do that we're going to create a test file, which is going to be a CSV file, so you can make this in Excel or Google Sheets or whatever you like. You can even do it in Notepad if you wanted to, just separate every value by a comma. It'll take you a long time, but basically we're going to have a table like this. In the first column we're going to put in every ID. So for older versions of CANBUS, more modern versions have more available IDs, but on this version for this particular dash and ones you're probably going to be working with, there's 2048 possible addresses. So in the first column we're going to put in 0 to 2047. In the next column we're going to put 8, because that's how many data bits we're going to try and send, and we're just going to fill all the other columns with 127, because the maximum value we can put in there is up to we can put 255 values from 0 to 254. We're going to go in the middle of the road and just send that down just to see what happens. Once that's done, you can see down the bottom what it'll look like in the CSV file, the ID, the DLC and the 8 bits of data. So we're going to go through and just fire that down to the device. So we need a bit of a test environment to be able to send data down to the dash here, so we can see what it's up to or how it reacts to us sending down codes. And it's going to be tricky, like, is it supposed to be hexadecimal, is it supposed to be decimal? But I've got it sorted for you already. I've got a Arduino sketch and a Python code which will be sending the data down. Now if you want that software or scripts or whatever, it's free. You just need to go onto my Patreon and join for free. Join for free, and then one of my posts will have all the code and everything there, so You don't have to pay anything, just click on, you'll see on the screen, join for free, and you'll be able to get it. So once you've got it, and you've got your Arduino Uno, I'm using an Uno, you're supposed to be able to use an ESP32 or a Pi Pico, which I would rather use, but I just can't get it to go for some reason, but it all works perfectly on this Arduino Uno, so I'll be sticking with that for my environment anyway. So everything you see here is based on the Arduino Uno. But what we're going to do is we're going to send this data down a line at a time to the dash and just observe what the dash is doing, and if we see any changes at any point, we note down what row we're up to, so we can come back and investigate that later. And we're just going to observe the dash just to see what it'll do when we play back this file. So we can see there on the screen it's playing back the data that's in the file, which is starting from bit 0 all the way down to 2000, and then the value for each of those IDs. And at some stage something should change on the dash. So we'll just observe the dials going up and down. Now if I was quick, I'd stop from importing and just see where those lines are, and then go back and investigate that address a little bit further. So it's gone through the whole file there. I saw some lights flicker, I saw some dials move, and I want to take a note of the address so I can go back and start sending more data to those IDs to see if I get some other things happening. So next step is to narrow down the IDs that are making things happen on this dash, and it was around the 500s. So I'm opening up the file in just Notepad, and I'm deleting everything in here that isn't around the 500 range, because I'm not really investigating that part of the IDs I'm sending yet. So I'll just scroll down and delete everything else. So I know within this 500 range something is making the dials move, and I'm not sure which line. So I've got a couple of test files, one in the streamer, and the streamer just goes from the top of the file to the bottom file and stops. There's one here called looper, and it's going to loop through the same file continuously, and as it's doing that we're going to delete lines until the function that we want stops working. So you might want to save it as a different file name. I'm just going to do the same file name because I can easily get the file back. So we'll start this loop up again. So we can narrow down quite quickly that something within that band of IDs is the one we're after. So we'll just individually delete every single line until the function stops. Then we know that line, or that ID, is the one that controls that particular function of the dash. I've obviously already gone through and done this, so I know which ID is used to drive those dials. So doing that testing, we also saw lights turning on and off, so we'd want to go back and try and track down those lines as well. And once we've got a set of IDs, you then start spamming each one of those with values from 0 to 254, so you'd have 254 lines of the same ID, and just varying through and just seeing what is turning on and turning off. So with that process I've managed to work out how to turn on all the lights that will function through CANBUS, all the dials that will function through CANBUS, basically every function. The only thing I haven't sort of worked out is counting up the speed and things like that, but I don't care because it's going to go on a sim rig. The keys, maybe it'll just work it out, I'm not too sure, I'm not too fussed about what that's going to do. So the keen observer will notice that this is not the same dash I used in the last video. The last video dash was an automatic, and I got all the automatic lights working on that one as well, but I was moving it all around while it was still powered, and I shorted something else and cooked it, so it's not with us anymore. So I had to spend another $20 and got another one, identical dash, plugged it in and it worked straight away. But this one is a manual one, which is better for me because I'll be mainly doing manual driving on the sim rig. That's about it for this video. If you made it this far, you should totally subscribe. So just a couple of questions we had there. Can I keep sending data to the dash and will it stop rejecting the data? Nope. Doesn't care, you just keep on sending data as much as you like. It just doesn't seem to reject it. There doesn't seem to be any particular sequence. It just, these things, dials and things, just seem to operate as their own entity, so I don't think you have any problems there. Maybe some funky European dash might be a bit different, but this one didn't seem to care. The other thing to note is the dash needs to be always updated with data, so it'll always have a default state. So when you turn it on, it's in its default state. When you send data to it, it'll turn lights on and off and dials will move, but if that data stops, everything will go back. So if you found out a ID which turns off a light and then it comes back on again, it's because you've not refreshed the data. So you need to keep on cycling through that data to keep the dash up to date. When I made the F40 dash, I was just telling the motor where to go. It never sprung back, but for this, it's like the dial's got a spring on it and it always wants to go back to home. If you want to use the same files I used today for your own testing, remember to go to my Patreon page and sign up for free. I'm not actually going to spam you, it's just a great place for updating the community on anything I'm working on, and you might see something there that'll be of interest. While you're there, definitely have a look at my shop to get these files, 3D print files to make these sim racing pedals. They're Hall effect pedals that are like the real thing, and it's a real cheap download. Aside from that, thanks for watching.